Good morning. This is Unit 2, Day 5 notes. We're going to go over complex zeros. So a polynomial function of x with degree n has n complex zeros. So this could be a real or non-real. Some of these zeros may be repeated. F of x is a polynomial function n greater than 0. Then your function has precisely n linear factors. The following statement is about a polynomial function f are equivalent. If k is a complex number, then we have x equals that number is a solution. This is going to be a solution of our function. K is a zero of the function. If it's a solution or a root, this is also called a zero. If we move this k over, we got to subtract k to move it over. X minus k is a factor of the function. Suppose that f of x is a polynomial function with real coefficients. If a and b are real numbers with b not equal to 0 and a plus bi is a 0, then a minus bi is another 0. They come in pairs. These are called conjugates or complex conjugates. Its conjugate is also a 0, right? Fundamental polynomial connections. It says, write the polynomial function in standard form and identify the zeros of the function and the x-intercepts of its graph. So this is actually pretty easy because it is already factored for us. So this one, they're asking us to put it into standard form. In order to do that, I actually need to FOIL it or multiply it out. I'm going to do these first because these are the conjugates, the complex conjugates, and this becomes real. I'll show you why. So my function is going to be, don't forget about the x plus 2. I'm going to rewrite it. X plus 2 times, and then I'm going to FOIL it out. My first two terms are x and x. This is x squared. My outer and inner are x I positive x I square root of 3, and then my inner are negative x I square root of 3. These will almost always cancel. When they're conjugates of each other, they're going to cancel. And then my last two terms are negative I times positive I, which is negative I squared, and then square root of 3 times the square root of 3 is the square root of 3 squared, which is just 3. I'll show you that in a minute. I'll simplify it first. So x plus 2, don't forget about the x plus 2, we still need to multiply that. X squared, there's nothing I can combine that with, it's just going to be x squared. Now these are always going to cancel. Plus x I squared root of 3 minus x I squared root of 3, these cancel. Now the square, or I squared, is negative 1. So this is actually going to be a positive, negative right here, times the negative is a positive. And the square root of 3 squared is just 3. Now, again, I'm going to have to multiply these. In order to do that, again, I have to FOIL. My first two terms are x times x squared, which is x cubed. My outer two terms are x times 3, which are 3x. And my inner are 2 times x squared, which is 2x squared. And then my last are 2 times 3, which is 6. And I cannot combine these actually, but they do tell us to put it in standard form. So this is not standard form. I need to put it in descending order. So f of x equals x cubed is first, 2x squared comes second, 3x, 6. And that's it. Okay, I just rearranged these two. That's it. Write a polynomial function of minimum degree in standard form with these real coefficients, which include zeros of the following. Alrighty. So I know that x minus 3 is an answer. Then I'm going to write it out. X equals negative 3. Okay? X equals 4. And x equals 2 minus I. Well, if x equals 2 minus I, then x has to also equal 2 plus I. I know that the conjugate is also a 0. Okay? Now, what we have to do is we actually have to FOIL these. My function, this is the minimum degree, has to be at least x plus 3. When we move it over, we add 3 to move it over. So x plus 3 is a factor. These are parentheses. X, when we move that 4 over, we have to subtract it. So x minus 4 is a factor. X, now this is going to be, we have to subtract 2 to move it over, so minus 2, and then we have to add I to move it over, so this is going to be plus I. And x minus 2 minus I is a factor. Now I'm going to FOIL these together and then these together and then multiply them all together, okay? You can just do one at a time if you would like, that's fine. So x times x is x squared minus 3 times x is 3x minus 4x is actually just negative x, right? 3 times 4 is 12, negative 12. So I combine the inner and the outer in the same step. You don't have to do that. Now what I'm going to do is I'm going to FOIL this. And I'm going to keep this term as one term right here. So I'm going to say x minus, and then I'm going to make this one term, and I'm going to FOIL it like this. X times x is x squared. My outer two terms is x times negative 2 minus I, so it's negative x times 2 minus I. And then my inner two terms is going to be negative x times 2 plus I. Yep. And then my last two terms are going to be positive 2 minus, oh, okay, well it's going to be negative and a negative is a positive. And then I'm going to actually just multiply it again, 2 plus I, and then 2 minus I. Okay, because they're not the same term, otherwise I would just square it, but they're not actually. This we have to FOIL again. Oh no. Okay, so this is x squared. This, you can distribute negative x times 2 is negative 2x. And this is also negative 2x. So this would be negative 4x. Negative x times I, negative I is positive xi, but this is going to be negative xi. They're going to cancel. So this and this one and this one cancel. Now, I have to FOIL this. 2 times 2 is 4. The inner and the outer will cancel. This would be 2i minus 2i. They cancel. And then we have a negative I squared. So negative I squared is just negative 1. So it's actually going to be plus 1 because it's a negative 1 plus 1. I still have x squared minus x minus 12. 4 plus 1 is 5. So this is going to be 5. I'm just going to erase it actually and put 5. You guys believe me. Alright, now I need to also distribute this. This is no longer FOILing. We multiply this term by all of them. Then negative x times all of them, negative 12 times all of them. X squared times x squared is x to the 4th. Minus 4x to the 2, and 1 is 3. Plus 5x squared. Now I'm going to change colors. Now we're going to do this negative x times these. Negative x times x squared is negative x cubed. I'm going to write it under here, negative x cubed. Because those are the ones I'm going to combine. Negative x times negative 4x is positive 4x squared. So this is plus 4x squared. Negative x times 5 is plus minus 5x. 5 and negative x is minus 5x. Alrighty, now I'm going to go to red and do 12. Negative 12 times x squared is a negative 12x squared. And then negative 12 times 4x is a positive 48x. Negative 12 times a positive 5 is a negative 60. Minus 60. Alright, so I tried to just put them underneath one another so I can combine them easier. So you don't have to do that. For f of x equals, I'm combining like my like terms. I didn't put anything underneath x to the fourth. There's only one of them. Negative 4x cubed minus x cubed is negative 5x cubed. 5 plus 4 is 9. Minus 12 is actually negative 3. So minus 3x squared plus 43x, and then still minus 60. I thought I was going to fit it. That's it. This is going to be my smallest degree possible. Some of them could be multiplicity too, so it could be bigger. I want you guys to try number 3. Alright, factoring a polynomial with complex zeros. Alright guys, so what I'm going to start with is doing p over q. So I know that our q is plus or minus 1. So it's actually just going to be plus or minus p, and that's 8. So the factors today are plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. So those are my factors of 8. Alright, so p over q is plus or minus these over these, which is just plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Alright, I'm going to try 1 first. So what I just did is I took 1. I know that 1 is a factor because it's one of these. And I plugged it in for x, and it gave me 0. So I know that this is one of the factors, and I'm going to make sure, I'm going to find out what the quotient is. So I'm going to put down I'm going to use synthetic division. You guys can use long, it doesn't matter. I'm going to put in the coefficients. So coefficient in front of the x to the fifth is 1, negative 3, negative 5. And I'm checking to make sure I'm not skipping anything. So this is plus 5. Oops, just put 5. Positive 5, negative 6, and then 8. Okay. We always bring down the first coefficient, which is 1. 1 times 1 is 1. Negative 3 plus 1 is negative 2. Negative 2 times 1 is negative 2. Negative 5 plus negative 2 is negative 7. Times 1 is negative 7. 5 minus 7 is negative 2. Times 1 is negative 2. Negative 6 minus 2 is negative 8. Times 1 is negative 8. 8 minus 8 is 0. Perfect. This is what we wanted. So I still can't factor it because this was a 5th degree polynomial. Now it's a 4th. I know one of these others are going to be a factor. I can try to, maybe let's just try 4. Let's try a bigger one first. If you plug in 4 into here, does it give you 0? Let's try it. So I'm going to put 4 into here, and then we put it in the house. And I'm going to put what's left over. So, or what I have as a quotient. 1, negative 2, negative 7, negative 2, negative 8. Okay? Bring down the first number. Use green. Always bring down the first number, which is 1 times 4 is 4. Negative 2 minus 4, or plus 4, is 2. Times 4 is 8. Minus 7 is 1. Times 4 is 4. Minus 2 is 2. times 4 is positive 8. Good. And this is 0. Perfect. This is 5th degree polynomial. This one is the 4th. This is the 3rd. It's still hard for me to factor 3rd degree polynomials. So what I'm going to do is one more time, I'm going to try to find a 0. I think I'm going to try positive 2, and it looks like positive 2 does not work. I don't think it's going to go in there. But what about negative 2? Negative 2 should work. Let's try it. Negative 2. Put it in the box. And I'm going to put these coefficients 1, 2, 1, and 2. They get shorter every time. We always bring down the first number. 1 times 2 is negative 2. And then this is going to be 0 times anything is 0. This is plus 1 is 1 times negative 2 is negative 2. And that is 0. So this is a quadratic. This is x squared. There's no x, so there's no middle term, and then plus 1 equals 0. Okay, well, I can still try to factor this. Move the 1 over. X squared equals negative 1. Uh-oh, I gotta take the square root of it. And this is when we will have a negative or complex 0. When I take the square root of a negative 1, that's I. And it's actually plus and minus this, right? It's the conjugate. So I know that this can be factored as x minus I and x plus I. Okay? Because this is x equals plus or minus I. Square root of negative 1 is I. If we move it over, these are going to be my factors. Also, they want all the zeros. We have these are our zeros. And we want all the factors. I'm just going to write them all together. X minus I, x plus I, x minus 1. Change the sign. X minus 4. And one more, x plus 2. Alright, these are my factors. Alright guys, I just want to go over this because I was going to skip it, but I want you guys to have more practice on this. So the complex number z equals 2i is a 0 of the polynomial, and this is an I. So I know that if x equals 2i, then my factor is going to be x minus 2i. And remember, the conjugate also has to be a factor. So x has to also equal negative 2i. So then it's going to be x plus 2i. This has to be a factor. I'm going to FOIL these. X times x is x squared. The middle is negative 2ix. The outside is positive 2ix. So those are going to cancel. And I'll get negative 4i squared for the last two. And the I squared is negative 1. So this is going to be x squared plus 4. Okay. If this is a factor, it says find the other ones. So find the remaining zeros. Well, we can use our long division. And you guys can use long division for this one since that's not x plus 4. I don't think we can use synthetic. So we have x squared plus 4 goes into this. 2x to the 4th plus x cubed minus 7x squared plus 4x minus 60, right? And I'm not skipping anything, so I don't need a placeholder or anything. Alright, x squared times x squared gives us x to the 4th. But I need it to be 2x to the 4th. So I also have to multiply x squared by 2. 2x squared times x squared gives us 2x to the 4th. Perfect. Now I'm going to multiply it. 2x squared times x squared is 2x to the 4th. 2x squared times 4 is this one. 8x squared. And since it's under it's x squared, I'm going to put it under the x squared. 8x squared. Okay? I'm going to draw my line. I'm actually subtracting. I'm not adding them. I'm subtracting them. I'm subtracting them. 2 minus 2 is 0. That's why we did it, to get rid of it. Negative 7 minus 8 is actually negative 15 x squared. Now I skipped something. I need to bring this one down. I have an x cubed minus this. So I'm going to divide it again. X squared goes into x cubed. X would have an x times. So plus x. X times x squared is x cubed. That's what we wanted. Good. X times 4 is 4x. I'm going to put it over here. You can't subtract it from an x squared. So what I'm going to have to do is actually bring it down. Okay, well, I'm subtracting. Don't forget that you're subtracting. We're not adding or anything. We're subtracting. I'm subtracting. Minus 0 if I have to, right? Minus. Okay. X cubed minus x is 0. That's how we did it, to get rid of it. So we have 15x squareds left over. It's a negative 15x squared. It's negative 15x squared. Can't subtract that from anything. And then 4 minus 4 is 0. So we're done with this. I'm going to bring down the 60 from way up there. Negative 60. All right. X squared times what will give us negative 15x squared? Well, I need a negative 15, right? Negative 15 times x squared is negative 15 x squared. Negative 15 times 4 is negative 60. Okay, but we are not adding. We are subtracting. Minus. This cancels. It's 0. Minus. This cancels. It's 0. Perfect. Now, this one we started with, and then we went to this one, which is 2, and then now we're going to go, and we're almost done, guys. We're almost done. So, we're left with 2x squared plus x minus 15. This is a 15, okay, Brittany? Plus x minus 15. And what we're going to do is factor it. And, I mean, you can use long division again if you feel so that you need to, but I know how to factor this. This is 2x, and x gives us 2x squared. The factors of 15 are 3 and 5. I'm going to try 3 first and then 5, and then I'm going to flip it and see which one it is. Now, the inner one is positive, so that means that the bigger one has to be positive, right? This one is positive, this one's negative. This is going to give me 10 minus 3. Okay, that didn't work. Well, let's try the other way. Alright, I'm going to say 5 and then 3. Now, the bigger one still has to be positive. So, I actually need to switch my signs. Will this work? This is 2 times 3 is 6. That's bigger than 5. But 6 minus 5 is 1. Perfect. Alright, equals 0. That means 2x minus 5 equals 0, and x plus 3 equals 0. I'm going to solve for it. Add 5 to the other side, divide by 2, x equals positive 5 over 2, and move the 3 over, x equals negative 3. Negative 3. So the zeros, or the factors, or the solutions, or the roots are 2i, negative 2i, 5 over 2, and negative 3. If they ask you to factor over the real numbers, sometimes you might not be able to continue factoring. Okay, so this one's actually pretty short. I'm just going to go over it. It looks like my factors are p over q, right? So p over q. So this is plus or minus 2. The factors of 2 are 1 and 2, plus or minus 1 and 2, plus or minus 1 and 3. But plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 1 over 3, and plus or minus 2 over 3. I'm not going to actually try the fractions first. I'm going to try like 1. Plug in 1 in here. I get 3 minus 2 is 1. Plus 1 is 2. Minus 2 is 0. Perfect. So 1 will work. Let's try it. So I put 1 in the box. Write down the coefficients in front of the x's. 3, negative 2, plus 1, negative 2. Okay? Don't have any space holders I need. Bring down the first coefficient. 3 times 1 is 3. Minus 2 is 1. Times 1 is 1. Plus 1 is 2. Times 1 is 2. And then this is 0. Now, I know that x minus 1 is a factor. But my other factor, or my other term, is 3x. We always decrease by 1. So it was cubed, now it's squared. Plus x minus 2. But I cannot factor this. I mean, you can try. You can even plug it into the quadratic formula. You're going to get something that's not right. It's going to be imaginary. So this is it. If you want us to factor over the real axis, the real number, this is all we got. We cannot simplify this term. We cannot factor this term. That's all I'm going to try today. I want you guys to work these out. And if you have any questions, please ask me. Have a wonderful day.